Okay, thank you very much for the invitation. Welcome to Ambassador, Chile. It's a surprise to me. I'm not going to change the talk. It's a real surprise. Most welcome. And thank you for the invitation. Yes, I'm back in town. I've been here only a couple of times, but I've been home. Me and my former child, former student, is here. And it's nice to be back in this field. So, what I'm going to do today is talk about the 2010 earthquake in Chile and the tsunamis. And I will focus on two different aspects of these events, these catastrophic events. One is sort of biophysical impacts in the ecosystems, the coastal, near-shore ecosystems. And the second one would be looking into people, into community. What happened to people there? You know, what we have learned from this catastrophe. So those will be the two aspects. The talk is based on two papers that have been published already. We published really fast. So the first paper, was published probably 4 months after the earthquake. And the second one 6 months, and there's another one coming. So the talk is based basically in two papers being published, and you can go there and look more details, and one paper which is going to be published, I hope, soon. So let us talk just a little bit. I'm not a geologist myself, but if you work in Chile and the South Pacific, in this area, you have to learn a little bit about what the earthquake is all about, because we're just there. This is the sort of general Pacific Ocean and tectonic plates situation. We're talking about this part of the world. And there are two plates here playing their roles. Is the Nazca plate moving towards the Atlantic, and the South American plate moves towards the Pacific. So actually the Pacific is expanding, and the Atlantic is shrinking, and the two plates playing a role. And Chile is just in the border. Chile and Peru are just in the border where these two plates meet together, one on top of the other. So that's part of our story, and it's going to be there forever, and we have to deal with it. So that's well known. Now, if you look with a little bit more detail, this area, from the underwater point of view, you will see that this is Peru over here, this is Chilean coastline, and this is 6,000 meters. This is the bottom of the ocean, if you like, and this is Easter Island. This is Chilean island. Easter passport, Easter Island. And there were another islands there. And there's a group of archipelagos here, Juan Fernandez and Ventura. I will be talking a little bit about this one, because very interesting, this archipelago is 700 kilometers from the coastline where the earthquake occurred. So I will call the attention to some of it. So this is the Nazca dorsal plate, and this is the Chilean elevation. So this plate is not only in front of Chile, it goes up a little bit up, but basically it's moving into that direction. Roughly at 6 centimeters per year. That's a normal displacement. While the South American plate, which is connected to the middle of the Atlantic here, it moves into that direction, and they meet together. And they meet together very close to the coastline of Chile and Peru, very, very close. Few kilometers from the coast. They don't meet in the middle of the Pacific Ocean, very, very close to it. So that's basically the situation. So if you were to see a sort of small model about this situation, what you have is the Nazca plate, which goes underneath the South American plate. So Argentina, Buenos Aires is around there, and it's moving into that direction. Actually, after the earthquake, Buenos Aires moved 6 meters to the east. It's incredible, They had to change all the GPS and things like that. So this is the Nazca plate, which goes underneath the South American plate, and this is the coastline. You know, the Andes Mountains will be there, roughly, and Argentina is in that direction. Middle of the Pacific Ocean is over there. So what happened is that these two plates, you know, they don't move all the time, you know, at that drive, and for many years they don't move at all, and energy is accumulated. So there are places where they move, and there are places where they don't move for hundreds of years. So energy is accumulated there. Instead of going 6 centimeters, it doesn't move, and energy accumulates there. Until suddenly, you know, that energy is released. And that's an earthquake, basically. That's an earthquake. It could be big earthquake. Those earthquakes tend to occur, you know, kilometers below 10 kilometers, 20 kilometers, 30, 40, 50 kilometers below the surface. But when the earthquake, and this one was only 6 kilometers, so the fault was only 6 kilometers there, the bigger is there. But that's basically the situation. Now, from the tsunami's point of view, you have to understand that if this plate, you know, suddenly moves upwards, and this place, the water column, which is here, will be suddenly displaced upwards. You know, 2 meters, 3 meters, 4 meters, 6 meters. That's a lot for you know, 1,000 meters depth. You know, suddenly the water column moves upwards, and there were the tsunami, you know, generated due to the movement of the water. As this plate goes up and this one slips down, if you like, this energy was liberated, and wave, a big wave is generated here, and that wave starts moving in all directions, north, east, west, south, all directions. Okay, the wave moving toward the west, towards the middle of the Pacific Ocean, gets a very deep ocean there. So the friction is very low and the movement faster. It's much faster than moving towards the coast, because as the wave moves towards the coast, the depth of the ocean is reduced, and therefore, you know, the wave moves roughly 600-700 kilometers per hour in that direction. While, you know, as moving toward the coast, you get, you know, 300 kilometers per hour, 50 kilometers, 20 kilometers, whatever, because it's more you know, it's shallow. So you could predict, you know, that a wave like this, you know, will reach an island which is 700 kilometers there in an hour. Roughly, you can predict that. While, you know, if the coastal area is here, it's only 100 kilometers. It's very difficult to predict, you know. You will take 10 minutes or 5 minutes, 15 minutes to get there, because it's pretty close. It goes slower, but the coastal area is much closer. That's basically the plate tectonics and the earthquake and the tsunami ideas. Okay, the February 2010 earthquake occurred in central southern Chile, a little bit south of Valparaiso, down to Concepcion. Concepcion is around here, so it's about, you know, 5 degrees latitude that was affected. Not all the country was affected. The fault was, the epicenter was there in a place called front of Constitucion. Big city here is Concepcion. That's Valparaiso, and Santiago is here. So from the oceanic point of view, this was the area most affected. You know, about between 500 and 600 kilometers. That's the fault. There was an epicenter in one particular site, but the fault was about 600 kilometers. That was the area most. So the basic facts of the situation. Just to give you a little bit of, we have learned a lot. Scientists in Chile have learned a lot after these events, because 20 or 25 of us, oceanographers, geologists, marine biologists, jumped into the situation and started doing research for the first time. It's difficult times, but it's an opportunity to understand what's going on in the system. So let us see what the oceanographers have learned about this event. We learned very important facts. As I explained to you, as the plates displace, there's a initial deformation of the water, top of the water, and basically two waves, one moving towards the middle of the Pacific Ocean, and the other one moving towards the coast. So this will be the first arrival of the tsunami to the coast. And in this particular case, because the fault was only 120 kilometers from the coast, that was the fault, it took about 15 minutes for this first wave to get there. There were no tsunami alerts in Chile. The system failed. But even if the system would not fail, that first wave, only 15 minutes, was very difficult to inform to the people because it was too close. But the very interesting thing we learned was that there was a second wave, huge wave, coming into the coast about 2 hours later. And what happened, and we have learned that out of this event, is that as the first wave get there, and this was start moving into that direction, remember that Juan Fernandez archipelago is 700 kilometers, so this wave, this tsunami wave, got there in 1 hour. 1 hour and 5 minutes. So if the tsunami alerts haven't been worked properly, probably will be possible to give the alert in this area. It was not the case. But as this wave moves into that direction, there's sort of vacuum here. This wave recedes, and this wave keeps going into that direction, and a sort of vacuum of water introduced next to the coast. And that vacuum needs to be filled with water. And if you look the platform in Chile to the north is very narrow, probably 5 miles, 6 miles. If you look the platform towards the south is wider, probably 20, 30 miles, talking about continental platform. And therefore, this vacuum which is here needs to be filled by water. And it was filled by water coming from the north because the ocean is deeper there and the water goes faster. So there was a second and probably third wave, 2 or 3 hours later after the earthquake, which filling this vacuum of water, if you like. I'll show you a photograph of that, real photograph. And that water, huge amount of water, came from the north because this water here, something needs to be filled here, okay? And the water runs faster here because it's deeper, and slower here because it's more platform is shallow. So we didn't know that until this earthquake. This has been modeled now. There are models that do that. Before we were working with models in Japan and California and whatever. And the oceanographers and geologists have learned a lot about that, being able to predict what's going to happen in the future. Okay, this is a real photo. This is a little port, which is a bay, which is Columo. And this is a photo, take the same place, exactly the same place. Taken in, somebody took that photograph to 2009, and that's the normal situation of that site during low tide. So that's low tide could be any year. It's a normal situation. And this photograph was taken exactly, you see this tree here and this tree here? It's exactly the same point. Columo, February 27, about 6 o'clock a.m. The earthquake occurred at 3:40 a.m. during the night. So this is about 2 hours and 20 minutes later. And you see as the water recedes, and this vacuum of water need to be filled, and the water felt, complete that space, came from the north. And that was the the second wave was the most, the one who made most effects in this system. So we have learned a lot about this. So if you were to see places like this one, and you will ask, the small-scale fishes, we know the system said the big monster came from the north. And that reflects, that the second big wave came really from the north. And destroy, it didn't came from in front of the sea, came from this direction. And that's the reason because part of the towns were destroyed and other parts were not. It depends on the orientation of those towns. And towns that are more oriented towards the south suffer less than towns oriented to the north, and so on and so forth. So this is the result, not of the first wave, tsunami wave, but the second wave 2 hours or 2 hours, 10 minutes later. We knew nothing about that until this occurred, and there's a lot of things we're making a lot of progress from the scientific point of view. This is not the first time I myself, as a scientist, have experienced earthquake in Chile from a scientific point of view. I have experienced 200 earthquakes or whatever, not all that big like this one, but this is the second time as a scientist I realized, that there were opportunities. And I published this paper in Science years ago, and there was the 1985 earthquake in front of Chile. During this earthquake, the coastal zone was uplifted 70 centimeters from 1 minute to the other. And if you're working in a rocky shore, rocky intertidal, something elevates, your size 7 centimeters, you realize that something's going on there. And we follow that coastal uplift in 85. We published a paper in 88. And we have another people been working. So this is not all that unusual, for scientists, marine biologists working on coastal areas in Chile. So let us go back to the situation. Let us go back to a little bit of biology. So this is it. So what is very interesting is that there's a couple of islands. There's an island there called Santa Maria. This is Concepcion, probably the third largest city in Chile. And there's an island there, which is about 80 kilometers offshore, not very far away. And the very important thing is that the fault occurred 100 kilometers from here. So this is the nearest coastal area you can go close to the fault. I mean, you can work in mainland as well, but that island is important. It's very important historical. So this is Santa Maria Island, 75 kilometers from Concepcion. We flew there, probably 2 weeks later, 3 weeks later after the quake, in a little plane. And the magnitude was 8.8. This is the 5th larger instrumentally recorded quake in the world. We got the first and the 5th. The first was 1960, the largest earthquake ever recorded in the world. And that was about 400 kilometers to the south of this locality. So that was 9.2, and this was 8.8. So talking big. And as I said, the tectonic fault, that's it, the quake occurred at that time, about 100 kilometers. So this is the nearest land you can put your feet close to and it's extremely interesting because this is the second large earthquake exactly in the same area. And during the first one, 1835, Charles Darwin was there. The Beagle, Charles Darwin, Fitzroy were there. They were not there exactly the day of the earthquake in Concepcion. They were in Valdivia, but they arrived into Concepcion in the Beagle, I think 2 or 3 days after the quake. And they reported, Charles Darwin and Fitzroy reported, what they saw. And very interestingly, particularly Fitzroy, Darwin was not a very good sailor at all. He didn't like to sail. Fitzroy was a very good sailor. And Fitzroy went to this island, the same one I showed you, Santa Maria Island, and did some measurements. And those measurements are recorded. 1839 publications. And Fitzroy visited that side, those which are in red. Visited that side, that side, that side. And then that's the island. And then they worked in midline sites, that one, and in Talcahuano and the Quinquina Island. So, and Darwin and Fitzroy realized that there was an uplift of the coast. Probably 2 meters, 2.5 meters, not 60 centimeters, 2 meters uplift. They talked to the fishers, and fishers took them there, and they asked, well, where did you collect your mussels and things like that? And they said, well, I collect the mussels out there, they were 2 meters. And they did some measurements in this site. So, my team, we decided to work exactly in the same places as Darwin and Fitzroy did, more than a century ago. And compare. So in black is the sites we visited. We couldn't work here because it was a big landslide and the coastal area almost disappeared in that area. We couldn't work in the Quinquina Island because it's a naval base and we couldn't get there, but we were in front of the Quinquina Island. So we used this opportunity. And we did this publication. This is a publication, which is about 3 months ago. So, after the earthquake and the tsunami, my small team of researchers in the Catholic University, we decided to ask 3 questions. The first, which are the coastal intertidal, and shallow water biophysical impacts of the earthquake and the tsunamis? It's more than tsunami, because that's the reason I use the plural. It's more than one tsunami. And we selected the Santa Maria Islands and sites in South Chile. Other researchers, work in different parts of Chile, we sort of concentrated there. Biophysical, what happened to the species, to the zonation pattern, and things like that. Second question was, which was the effect of the tsunami? On the coastal artisanal small fisheries communities population. We've been working with these communities for years and years. So we knew the people and we have access to them. And what about devastation and survival? And that paper was published a couple of months ago as well. And the third one, we're still working on that, is asking the question, since this was a tremendous impact in the system, let us ask people perceptions about ecosystem services before and after the earthquake. Which were the perceptions before? Let us ask people, not scientists, about ecosystem services. I'm not talking about fisheries. I'm talking about cultural landscapes, everything which is there, and we're working on that. So those were the three questions we were able. No money, because there's no way you can run to government and foundations and say, I need money to do the research. We did it, with the little money we have here and there, because it's an opportunity to do research. So this is the first question, and I showed you that slide already. These were the elevations reported by Fitzroy and Darwin, 1835. They visited, the Santa Maria Island, the island I showed you, and they talk about 2.7 uplift of the coast, tremendous uplift. The north, the center, and the south of the island, I show you the points. And then in mainland, they report between 2.4. So, 2 meters, 2.4 meters uplift. So that's known from the literature. And they were able to do that, and we did the same, because working in rocky intertidal system, you know where the species are, and you can see belts. This is one belt, this is another belt, and things like that, and you've been working there for years and years, you know the tides, and you can compare, if this system is elevated 2 or 3 meters, you will see it. It's not that. And you can do preliminary measures on bioindicators. We call them bioindicators. We know that when this is a low tide, when the tide is up, this side will be fully covered, while this will be still, with a little water. We know sonation patterns quite well. So this is what we need, in a normal situation, the water will cover, the mussels in high tide, and they will cover some algae, pink algae, very, very relevant one, and kelp and things like that. And if the system is elevated, 2 or 3 meters or whatever, you will go to the sites and the high tide will be there, the low tide will be there, while before were, 2 or 3 meters displaced. And if you give the system, a few weeks, you can see the difference. And that's what Darwin and Fitzroy basically did the same. This is a preliminary approach, the satellites and things like that, and there is then time to confirm that it's speaking. So we use the same system. So this is where the Santa Maria Islands, looking towards the ocean. This is high tide. This is not low tide, this is high tide. Okay? And this is the situation. These mussels, are totally uncovered of water. The water reached that point before. This side was elevated. And all these mussels, are dead, 2 3 meters. And this one you see white here, lithotramium, as crustacean algae, which is pink. This pink, which is there. And thus it's elevated and it gets in contact with the sun and the air, okay, they get white because they're dead. Before they were pink, really pinky area. So you can do measurements here, basic measurements. You know before where the mussels were, and in this particular site, the uplift of the coast was about 3 meters, not 3.4 meters. Huge. So this, once again, opens an opportunity to revisit this site and see how, communities been impacted by this catastrophe, can recuperate it, how much time it takes, and so on and so forth. So this area was about 3 meters uplift. Huge. So nature were totally transformed. And a lot of animals that died. And this is, this is high tide. It's myself. And you see, algae, like the ones I showed you before, that normally are covered during high tide. And this is high tide. So by doing this, we not showing you more, but this fantastic photo of this rock probably was moved by the earthquake and the tsunami probably, and low tide was there before. So it's fantastic. Most probably, Santa Maria Island is a product of this. This is a consequence of this earthquake being going on for hundreds and hundreds and hundreds of years. And there's an uplift. Now we got the island, but the island were not there, 2 million years ago. So this is a product of this fantastic situation. Tremendous opportunity to work, in resettlement and reestablishment of the community. So basically, we don't give you a lot of details. In the Santa Maria Island, we were up to 3.4 meters, while in mainland sites, less than 1 meter. The different elevation, different uplift in this area. These data were corroborated later, and this is satellite and other sort of measurement, and the full area here. This is the geophysicist studies. The whole area, not only the coast, okay. The whole area in the ocean were elevated about 2.5 meters. And that was what it caused the first tsunami wave. So this data is corroborated. Not giving a lot of details, but it's not only that the rocky shore was elevated, but everything that was there died. And in this area, used to recruit a lot of species, economically important, that recruit there and then move to the sublittoral. And we don't know exactly the impacts, of these events from the fisheries point of view. It's little known about it. The tsunami, took inland, a lot of giant humble squids. These squids are, probably 1.5 meters, 20 kilos each. Huge squid. It's called the giant squid. And the tsunami just, brought thousands of them to the rocky shore, and crabs and things like that. So tremendous impact. Okay, the second question, and this is a paper was published recently, is were the effects of the tsunami on the coastal artisanal fisheries communities and population. This is very interesting. This is more sociological sort of approach. We've been working with all those communities. Every one of those is a community of small-scale fishers. We cover, 100% in this region, 90 here, and it was difficult to get here. 2-3 weeks later, when there were no roads, difficult to get there, so we were able to cover more. But we decided, to ask two questions to people basically, not easy task, because were difficult times. How serious was the impact? We did field questionnaires, very, very, 1 or 2 months after the quake. And we concentrated in leaders instead of concentrated in, asking people around, concentrated in leaders of these small-scale communities. These are very well-organized communities. VM knows about it, Carol knows about it. They're always leader, and they've been there for many years. And then what factors facilitate survival of fishers community? Not everybody, but the fishers community, we were interested in how many people died there, how many were fishers, how many were not fishers, and which were the factors. Because understand that could be very important, not only from the science, but for the government as well. And we did, different questionnaires and things like that. We did it directly, in direct conversation, or by telephone and things like that. In some cases, we couldn't get to the. This is what happened in this community. The bridge is totally destroyed. I was telling Carl that this is a little estuary, probably 6 kilometers, in which a lot of gracilaria and algae was extracted for years and years and years. It's a very shallow estuary, 3 or 4 meters, and it was elevated 3 meters. So now it's 60 centimeters water. It's no more gracilaria, no more algae, no more anything. The system disappeared. And what people doing there, we don't know yet. But it was tremendous impact in the rocky shore. Show you a few pictures. Not only small boat, but middle size. A lot of destruction. In this area, the 6 kilometers area, about between 27 and 30% of the small-scale fishes in Chile occur. So it's an area in which 30% of the small-scale fish is concentrated. And more than 40% of the landings of small fish is concentrated there. So it's not any area in Chile. It's very important from the livelihood and recollection and food and things like that. We quickly recognize that about 50% of the small boats were destroyed, diving gear. In some cases, were not data before, so it was very difficult to calculate. But there were enormous material impacts. But the most important thing we learned is that we tried to discover, how many people have died in that area from the tsunami, separated from the earthquake. We were interested in the tsunami. And it took us several weeks to find out that about 190 and the total death was about 500 people. But probably 200, were affected directly by the tsunami on the coast. And very interestingly, only about 8 and 12, probably 10 fishes died. only 10, out of 200 were fishers. The other were occasional visitors, holiday makers, other sort of people. Very, very, very interesting result. Because the number of people living, from fishing in this area is enormous. Much more than occasional visitors and things like that. They have their houses there. And nonetheless, very few died. Very few. Due to the tsunami, trying to separate those things. And then we asked the question, okay, what factors facilitated the artisanal small-scale fish evacuation without tsunami warning? Because it was not tsunami warning at all. Alert at all. There was not. And we identified 3 things. We asked the question about the natural indicators, say the magnitude of the earthquake, observation of the sea. The moon was very important because that night was a full moon. And that was a coincidence. And people was able to run because of the full moon. So that coincidences in the thing that people recognize. It's very important there was a full moon. That was very, very important for them. Then we looked into human design system. Tsunami warning, alerts, training, evacuation, signals, and things like that. And then sociocultural resources, local ecological knowledge, and networking between the people. And we tried to ask, in a scientific way, those questions to people. I'm sorry about the Spanglish here, but that's very important. This is important. This is less important. It is not important at all. I forgot to translate. So these are the results. Reports. Very interesting, from the government, I think. The natural indicators were extremely important, and local ecological knowledge and social networks, extremely important in these communities. Social networks were there. Local ecological knowledge was there, particularly because the 1960 earthquake, although it was 1960, didn't, making tremendous impact in the people depending from the sea. While, radio alerts, authorities signaling and things like that were extremely not important at all. Some of that didn't occur at all. But this is very important. This is very important to understand. If we want to build on in the future, Chile needs to take into account local ecological knowledge in these communities, not only science and bureaucratic things. This is what is built in these communities. So you ask the people and say, yeah, okay, I've been told, the fishers, I've been told if an earthquake is so strong I cannot stand up, I have to run to the hills. That was there. That was built in the communities. And they did. And that was not built in the occasional visitors or holidaymakers or people coming from big cities and big towns. And therefore, out of 200 people who died, 10 were fishers, 180 were occasional visitors and holidaymakers. I think it's very interesting finding, we have communicated this finding to the FONEMI and to the institutions in Chile, because I think it's important to understand this situation. In summary, we think that the successful answer to the tsunami evacuation by these communities can be explained mostly by sociocultural factors, like whatever you like to call, and for a correct reading of the natural earthquake and tsunami indicators. As I said, it was a coincidence, it was a full moon, and that saved a lot of life. In Chile, it exists, it does exist a culture in this community with regards to disaster such as earthquake and tsunamis, which is really, really rooted in these communities, and the country needs to learn about it. But not so in coastal occasional visitors, so targeting in holidaymakers and occasional visitors policy need to be developed. You can signal things, in the side, but if people is not aware or alert, so this is, can be policy making there. But the absence, they did not respond. I think last but least, the authorities failed, the authorities know that failed regarding tsunami alerts. Things been advanced in the last 6-7 months in Chile. And I think one is from the first tsunami wave, the Juan Fernandez people, Archipelago could be saved altogether. It was 1 hour later than that. But for the second wave in Costa Mesa, if an alert and a good model was there, could save many lives. So this is things we have to make more progress in my country. I think lessons in the future Chile we will hit it. Next time probably not in Chile. That's where more energy being accumulated for 120 years. There's enough energy accumulated in northern Chile, 121 years already. So the next thing is going to occur. When? We don't know, Tomorrow, day after tomorrow, 50 years later, we don't know. But the next place in which this sort of energy being accumulated is in northern Chile. And the country needs to absorb the 210 lessons, to implement, to reinforce public preventive policies. And particularly along the coast, the existing earthquake and tsunami, so what I call survival culture among artisanal fishers must be a pillar. We must learn about it, and lake is extremely important. Natural catastrophe, that's the last lesson. They're terrible. And it's difficult to go into these places and ask questions to people, it's terrible. And you have to do it soon after. You cannot wait 2 or 3 years because things will go away. They're terrible. They do represent unique opportunities. It's not that we enjoy doing this research, it's that we have to do this research to understand, what is going on, not from the biophysical point of view, but from the people's point of view. Extremely important. And there are unique scientific opportunities to carry on novel research, and particularly to integrate disciplines. We did this work with 2 social scientists, 2 marine biologists, and 1 economist, and we had a team which we were integrated by 2 or 3 leaders of communities at the same time. Because it was not easy going into the communities without, including the leaders of the communities. That was the team, about 10 people, trying to get into this place as soon as possible and trying to understand what happened. Thank you very much.